this time I'm going to start getting a sprite to move based on some input. So this will typically be like the player component. So I added in a component, player logic component, I called it for the time being, and I'm going to start writing a function which is going to take mouse input and get the player to rotate and move towards the mouse position. But first I started to take out the other components just so I had only the player component, and I realized that the game crashes if I don't initialize a full set of renderable components. So it means refactoring a bit to be able to have a variable number of entities in the game, which is a useful thing. So I'm just crossing these problems as and when I hit them. So here I'm just modifying the render sprites function to check if an entity has a component renderable, and a sprite, cbuffer sprite function, because this is to draw a sprite. I timed it, and it's not very expensive to iterate over a list of entities and check if they have the component. So for example, if I had a list of entities and they didn't do anything, an expensive function wouldn't take any time. And as I'm going along, it's starting to take more shape. For instance, the player now has his own update function, and then in the future I can see that I need cbuffer update function, just splitting up all these entity updates, or component updates I should say, into separate functions. And that's essentially what will define a component. A component could have an update function which we check, loop over the entities and check they have the component, and then perform the update on them. So I'm always performing operations on similar data. So if I come to update enemies, there should be enemies contiguously stored in memory for me to process, and that would be more efficient for cache utilization. The reason I'm not using virtual functions and inheritance to define the components is so that I don't cause stalls from instruction cache misses. So I'm just calling player control, and then I loop over the entities to see which ones are the player, and then that's the cost I pay instead of virtual table lookup and instruction cache miss. And because I process similar items together, I will have fewer times I will need to hit the instruction cache. And it should also keep the code that needs to go into the instruction cache smaller, so again, more efficient. And that's why I chose to use an entity component system, because it works quite well with C, and you don't need to use classes and inheritance and things like that to be able to get components or functionality that you want to reuse. Here I've split them up, so I've got an update for the entities like I had before, which was assigning the random position, but also I had the player update, and he was staying still because I wasn't controlling him. And then that's what I'm doing now, getting the mouse position, and then based on the mouse position I'm going to work out the rotation the player needs to face towards the mouse position, and then also move towards that mouse position when I click. Basically going for like a kind of RPG style input mechanic at the moment. Something like Diablo would be an example. And for the time being, all my coordinate space is in normalized device coordinates. But that will change in the future when I need to have a level to move around in, and I want the screen to move with the player or something like that. The cbuffer sprite update function takes a rotation value and turns it into a 2x2 matrix, which can be used in the shader, so I can avoid doing sine and cosine in the vertex shader. And here I'm having problems with the rotation not being quite correct. And frustratingly, a-tan2's function parameters take the y parameter first and then the x parameter. And I'd originally put them in the wrong way round. And the final solution was to pass in a-tan2f minus y and minus x. That was because my vector was the wrong direction. It was going from the player to the mouse pos, from the mouse pos to the player, as opposed to the other way around. So at this point I needed to add some extra component information for the player to use. I'm calling this a player control component, and it's going to contain some information. Firstly, a destination position for where he's going to walk to, but also in the future destination rotation and timers and things like that can go in there. I added two modes for the player, so he's got an aim mode, which is when you're holding down shift and he'll turn to face the mouse cursor, and then if you're not holding shift then he doesn't move where the mouse, look at the mouse, he'll just stay still until you click, and then that will set the destination position, and then over time the player will move toward the destination position. If I stay with this system, then the moving towards the destination position will also include pathfinding, which I might find I'll group together into a different component, a pathfinding component, and then entities can use it as well. Not entities, sorry. Well, any entity can use it, but things like enemies or AI or anything else could use a pathfinding system if it needed to. Firstly, I just set it so that the player moved directly to the destination position immediately, just to test that was being set correctly, and that was working. So the next thing to do is just to get the player to interpolate toward that position over time. And here is the sprite. He's moving towards the mouse where I'm clicking and facing in the correct direction as well. So decent session.